All right, guys, this video is going to take us through days 3 and 4 of our online self-paced learning. This is laws or properties of exponents. Today we are going to be able to explore properties of exponents through patterns, and we'll be thinking about how looking at those patterns can help us identify what the properties of exponents are. Just a reminder that on Thursday we have an MYP task. So we are going to be doing some powers practice as sort of a recap, and then a properties of powers discovery, some stations, and then a challenge practice at the end. So this one is a solo, but the first thing that you are going to do is fill in the table for powers of 10. So you have numerical expressions, so that looks like 10 to the 4th power. You've got expanded form, which could look like a 10 or a 1, or it could look like 1 over 10 times 10 times 10. We're expanding to show every time we're multiplying by 10. And standard form is what we're used to seeing as just like the number 10,000 or 1 over 100. So use the patterns to fill out the table, and please pause this to do that, and do not go on to the solutions until you have finished. Definitely should not be going on into this next slide until you have finished the practice. So if you were clicking go on, that means you have finished the practice. At this point, you should have a partner, and you're going to do a quick self-check. And what I want to make sure we talk about are a couple of things. So we talked about this with scientific notation, but it's much easier to use this numerical expression, or writing a number as an exponent, than it is to write out the expanded form or even the standard form as our numbers get really small or really large. I also want to point out some patterns that you should notice as you are looking down the table. And that is that every time the numerical expression decreases by a power of 10, so does the standard form. And there's one fewer 10 in the expanded form. And so what I want to ask you is, do you think that pattern exists when the base is something other than 10? Because today we're going to be looking at bases that are not 10. So think a second about that. If, like here, when a power of 10 when we decrease by a power of 10, we also decrease by a power of 10 in our standard form. Do you think that pattern is true for other bases as well? So the next thing that you are going to get, and you are going to do this with your partner, is you are going to get one of these papers to complete. And it's a base that's other than 10. So some of you will have a base of 2, some of you will have a base of 3. Some of you will have a base of 1/2, and some of you are going to have a base of 1/3. So please pause this video and complete the practice with your partner. All right, once you have finished completing the table with your partner, please go on to the next slide. You and your partner are going to now grab the answer key. And I want you to do this in a really specific way. So if you had table A, you're going to compare it to table B, and then B to A. If you had table C, you're going to compare your answers to table D, and then if you had table D, you're going to look at table C. And I want to know what you notice. So talk to your partner about, what do you notice about table A and B, or tables C and D? So pause the video for a second and talk about what you notice. So one thing that I hope you noticed is that it didn't matter what our base was, that any number to the 0 power was 1. And the other big piece that I hope you noticed is the relationship between the whole number base raised to a power and the fractional base raised to a power. So 2 to the 4th power is 16, and 1/2 to the 4th power is 1/16. And then notice what happened as we went down the table, all the way down to 2 to the negative 4th power is 1 over 2 times 2 times 2 times 2. And then look what happened over here. We have 1/2 raised to the negative 1/4, or the negative 4th power, and it became 2 times 2 times 2 times 2. Later in this lesson, we'll get into what we call negative exponents. The other thing that I want to point out, we talked about how with the base of 10, every time we went down by a power of 10, the standard form also went down by a power of 10. So if we're looking at this powers of 2, we went 16 to 8 to 4 to 2 to 1. So each one is half of the one before it. And if you had the base of 3, I hope you noticed that each one was a third of the one before it. It went 81, 27, 9, 3, 1, and then it just kept going. What I want you to record in your notes, though, is this piece of information here. So numbers that have these inverse exponents or opposites, like 4 and -4, and reciprocal bases. Think about fractions and reciprocals. The reciprocal of 2, or 2 over 1, is 1/2. So numbers with inverse exponents and reciprocal bases are equivalent, which means something like 2 to the 4th power is equal to 1/2 to the -4th power. Both of those are 16. So please pause the video for a second and record that idea along with the diagram and the arrows pointing to each word in your notes, and then go ahead to the next page. Most of the practice for these lessons 3 and 4 are from these station activities that you should see around the room. And so there are 4, and they're for 4 of the 5 properties of exponents that we're going to talk about. So you should have this handout that's here on the left. That's going to be kind of your takeaway with all of them in one place. And on it, you will add to this numerical example column as you go. These instructions are posted at each station as well. But when you get to the station, you are going to examine the definition and the why does this property work box. And then you'll use that to complete the 4 practice problems. Once you've done the 4 practice problems, we're going to do this activity called Make One, Take One. You are going to create a sample problem on a sticky note that follows the property that you are currently focusing on at that station. And you should take a sticky note that someone has already made and attach it to your notes and solve. There's a place for it right on the notes you're grabbing at the station. I have 4 of them up there, so you can feel free to choose one of mine. This is good, especially if you're one of the first few people, you still have one that you can take. Finally, you are going to, just like I was saying, complete the numerical example box on your properties of integer exponents. And you can make your own example if you want. You can use one of the examples from the paper if you want. My recommendation would be to really test out your skills and make one on your own, but it's up to you. So at this point, you should pause the video. If you need to go back and listen to instructions again, you can. But the few slides after this are going to be solutions to the station. So if you go on to that now, you're kind of ruining your ability to practice it. So pause the video. Pause the video. Just want to make sure everyone paused the video. So I'm just going to go through these 4 stations, some solutions. So our product of powers rule or property states that the product of 2 expressions with the same base, that's our catch, we have to have the same base, like in both of these examples here, the base is x, equals the base raised to the power of the sum of the exponents. That is a fancy way to say that if I have 2 powers and I'm multiplying them together, bases are the same. All I need to do is add the exponents. And so look at this example with 2 to the 3rd power times 2 to the 4th power. You can see this all written out. 2 times 2 times 2 would be 2 to the 3rd power. And 2 times 2 times 2 times 2 would be 2 to the 4th power. And if I write that all out, I have 7 2's, which is 2 to the 7th power. And notice that 3 plus 4 equals 7. So if we are looking at our examples here, my base is the same, 1/5, 1/5, and I will add the exponents. So this would become 1/5 raised to the 11th power. This would become 7, be careful here, 3 plus a -2 is a 1. Be careful here too, do you see how integer rules come back? This would be 2 and 5/10 to the -2nd power. And if we're thinking ahead to how those negative exponents work, that could also be 1 over 2, this would work. Yikes, that's a decimal. 2.5 squared. This one here. Remember, anything raised to the 0 power is 1. So you could look at it like that, or we could just add our exponents involving 0. This would be 2/3 to the second power. Let me put parentheses around that so we're not confused. All right, next up, this is our quotient of powers rule. And so if you think about it in terms of multiplying and dividing being opposites, this shouldn't surprise you. When I have 2 powers and the bases are the same and I'm dividing them, we subtract the exponents. So here we have 7 to the 5th power divided by 7 to the 3rd power is equal to 7 squared. 5 minus 3 is 2. This is another one where we need to be careful of our integer rules. So this one, the bases are the same, 4 and 4. 5 minus 2 is 3. This would be 4 to the 3rd power. We have -8 is the base, and 4 minus 3 is 1. We have 2 as the base, and 8 minus 10 is -2. Be careful of that one. And then we have 1.5 as the base, and 5 minus 4 is 1. So that would be 1.5 to the 1st power, or just 1.5. All right, this is the power of powers rule or property, which says that an exponential or an exponent expression raised to a power is equal to the base raised to the power of the product of the exponent. So in this one, we're multiplying exponents together. So here we have 3 to the 8th power raised to the power of 4. So we've got 8 times 4 is 32. The base stays the same. Okay, so in this first case, the base is 2. 2 times 3 is 6. Yikes. There we go. The base is 1.3. Don't get thrown off by the double parentheses. It's just because we've got a decimal. 3 times 3 is 9. Got this nice fraction of -1/2. Oh my gosh. There we go. And 2 times 5 is 10. And we have the base of 10, -6, be careful, times 2 is -12. And this last one is just a recap of the negative exponents. So this idea that 1 over 5 squared would be equal to 5 to the -2nd power. So if I have 1 over 4 to the 6th power, this is like saying 4 to the -6th power. If I have 1 over 2 cubed, that's like saying 2 to the -3rd power. If it's going the other way, 10 to the -3rd power is equal to 1 over 10 to the 3rd power. Once you've done all these, I want you to try this last set of challenge questions. So I want you to pause the video. Let me read you instructions. So you are going to be writing each of these as a power of 2. Your answer should be in the form of 2 raised to a power. Some of them will be easier than others. So please pause the video and give it your best shot. All right, so this is our product of powers. So same base, the base stays the same. 6 plus 5 is 11. This is our quotient of powers. So 10 minus 8 is 2. Base stays the same. This is our product of powers. So 2 times 3 is 6. Base stays the same. This is another quotient of powers. 3, be careful, minus 8 is -5. So this would be 2 to the -5th power. And then they get more interesting. 16, if we're thinking of powers of 2. 2 squared is, or 2 to the 2nd power is 4. 2 to the 3rd power, 2 times 2 times 2 is 8. So I just answered H. And 2 to the 4th power, 2 times 2 times 2 times 2 is 16. And then if we're thinking about negative exponents, then 1/16 would be 2 to the -4th power. And 1/8 would be 2 to the -3rd power. Please be sure to ask any questions even about this challenge one if any of those did not make sense. But we are officially finished with scientific notation and laws of exponents. Good work.